This section examines idle speed control systems. Base engine idle speed may be set by adjusting a screw on the throttle body. This sets how much air flows through a bypass passage from the intake air side to the manifold side of the throttle body. However, if more load is put on the engine during idle, its idle speed may fall to a level where the engine stalls. Higher load can be caused by extra frictional resistance that occurs in a cold engine and by electrical loads from headlights or the cooling fan. Shifting an automatic transmission into a drive range or engaging the air conditioner compressor clutch will also cause a drop in the idle speed. The extra air needed for a cold engine can come from an auxiliary air device. This one has a connecting hose from the intake air side to its controlling passageway and a return hose to the plenum chamber. It bypasses the throttle plate when it's in operation to provide the extra air. The control unit reacts to this additional air by metering additional fuel. This makes more air-fuel mixture available during the warm-up period. How much air bypasses the throttle plate can be controlled automatically by the ECU. It receives data on idle speed and idle conditions and uses it to provide an output to a solenoid-operated taper valve or to a stepper motor pintle. The valve varies the opening of the bypass passageway and changes the idle speed to suit. The position of the throttle plate can control idle speed automatically. A DC motor works a plunger in contact with a lever attached to the throttle spindle. As idle conditions change, the control unit can extend or retract the plunger, which increases or decreases the throttle plate opening. This provides the desired idle speed. If the control unit is programmed to maintain a fine control of the idling speed, perhaps to within 100 RPM, ignition timing can be used. Advancing the ignition point increases engine speed, just as retarding it decreases it.